Students, that force that we have seen that from the earlier part, and we have calculated that how we can enhance the strength and what would be the direction of the force that has been generated with the help of Fleming's left hand rule. Okay, now come to the part of applications. What basic applications we can see and we can use in day-to-day life with the help of this force that we have generated with the help of current carrying conductor and the external magnetic field. So here the basic and the most important topic of this session is electric motor. Now, what is electric motor? First of all, let me tell you, it is a rotating device, and you might be seen this motor in your house in various applications also, like in mixer grinder, in washing machines, जो घूमता है, rotate होता है, that is all due to motor, and the fan that is rotating again, that is all due to motor. Okay, so it is a rotating device जो rotate करता है, ठीक है? It converts electrical energy into mechanical energy. You know that when we are providing electricity, then only it is able to rotate anything. If we are not plugging in the wire and putting it on switch on, so how does it producing and making, like mixer grinder तब तो work नहीं करेगा like हवा में. तो when you are putting it on electricity and switching it on, then only it will work. So basically what is doing here, we are converting this electricity into mechanical work. What is mechanical work? Mechanical work is like related to simple mechanism, simple machines, or complex machines also you can say. So but machine parts is available जो कि बाहरी रूप से कोई काम कर रहा है. Okay, when you are pulling something, so you are doing some mechanical work here, because our body is just like a machine also here. So machine, when it is doing something, we can say that it is doing mechanical work. जैसे लोडर होता है, क्रेन्स होते हैं, they are all doing like heavy load को uplift करते हैं and put करते हैं. So what is they doing? They are doing mechanical work. Okay, so cutting, like mixer juicer is grinding everything. So what is they doing? They are doing mechanical work. So this basically motor converts electricity. When we are supplying any electricity, so it will convert it into the mechanical energy. Now the third point, they are used in electric fans, refrigerator, washing machines, that I have already given you the examples part. Okay, now this is look alike like a brief structure of the motor, but nowadays you are not going to, when you are opening the motor, you are not going to see such a part. But this is a easiest thing that we can use to draw the diagram, and we can enhance our knowledge with the help of this, that how does motor works, what are the basic things that we can see here. So what are these? As you can see here, we are having a external magnets. Now see students, as I have told you, none of the magnet is like this, that only north pole is present there. None of the magnet is like this, that only south pole is present here. You always find that some kind of magnet that is having both north pole and south pole. If it is south pole, so north pole would always be there. Then how does we have made a diagram like this? Okay, so students, this is not a single magnet. This is actually, we have taken the part of horseshoe magnet. Okay, so making a horseshoe magnet wholly is not a thing that we have to show here like this. Okay, so this is what a horseshoe looks alike. So what is this? This is horseshoe, and we are taking the only thing north and south pole of this horseshoe magnet, and where we have just not drawn all these things. So this is how this is a part of horseshoe magnet. I hope this is clear to you. And what other things we have taken? We have taken here a split ring. We have taken a brushes here, and this is a simple electric motor example, and here you have switched it on with a key and a battery. Okay, now here we can see that there is an axle part also. Now this axle part is like this cylindrical thing that is rotating like this. Okay, it is going to be rotate like this. ये rotate होगा यहाँ पर. Okay, this cylindrical thing is going to be rotate like this. Okay, now it is attached with a split rings. तो split rings क्या है? The C-like structures that you are seeing here like this, that is attached to this rod, that is attached to this axle, it is known as split ring, okay? And these are the brushes, okay, like this. So this is what it looks like. This is what the motor looks like. Now let us see on what basic principle, as we have cleared that it is working or converting the electricity into a mechanical energy. So in the same manner, how it is going to be, on what basic principles it is going to be work. Now see here, principle of an electric motor. What is it? An electric motor works on the principle that when a rectangular coil, as we have seen in the diagram, there was a rectangular coil, is placed in the magnetic field. This is a magnetic field that is produced by this horseshoe magnet, okay, and a current is passed through that coil. जो coil थी यहाँ rectangular coil, so on that if we pass the current, so you know this is a current carrying conductor. Now this is a coil, current carrying conductor, and it is kept in between the magnetic field. Now it will certainly feel a force because of its own magnetic field and the magnetic field that is produced by the external source. So they both will clash together and will produce a certain force. So what is that force? So that force is going to be used continuously and keeps it rotating. And when this coil is going to be rotating due to the force, as it is attached to the axle, so an axle will also rotate. And now with the help of this axle, you can use anything. Like it, if अगर हम इससे कुछ knives इससे attach कर देते हैं like this, so ये मिक्सर जूसर की तरह वर्क हो जाएगा. अगर आप इससे फैंस की फिन्स को लगा देते हो, फैन लगा दिया, तो ये फैन की तरह रोटेट होने लग जाएगा. But the mechanism behind all the things is like the same as given in this principle. So students, this is the basic principle on which electric motor works. Now let us see the construction part of it. Okay, for construction, we are having certain things, we are having certain points. Let us take it one by one, and before that we should have the diagram part also. So see, on construction I have already told you there will be a rectangular coil A, B, C, D. It is like this only, A, B, C, D, and that is again connected with the wiring, and that wiring is attached to the battery so that it is going to have a current, electricity current, okay. And that is with the help of these two brushes. We are having these two brushes X and Y. Okay, so these are carbon brushes basically, and you know that carbon in a graphite form is a very good conductor of electricity. So this is what that brushes are made up of. Okay, so from the battery we are going to have the current here, and that current is going to be flow by keeping in contact with, because these brushes here are in contact with this kind of split ring. We can say it here as the split ring. It is like a commutator. These are what? These are commutator. Okay. So what are they helping? They are just helping it like this. They are having, this is a part as the insulator and this is connected with the rod. So what is happening here? Directly we are attaching this rod with this so that they can rotate on this commutator. So this rod can rotate, and this split ring, because they are fixed here, they don't have to rotate. Otherwise, अगर हम इसको इस तरीके से नहीं बनाते, like the split ring is having, so what will happen? The coil is going to be rotated with the force, and that is again going to rotate each and every wiring here. So that is going to be a very complex thing, and eventually it will not work perfectly. Okay, so that brushes here is helping to generate, to providing the current, and that current is going to provide in this split rings, and that split ring now is connected with this rod. So this rod is now having the electricity, but we are this is insulator. This rod is going to be moved, just a move, because this is connected with this split ring. Okay, now this is going to be connected with the coil also. Okay, so coil is going to be rotate. Coil is going to be rotate. Accordingly, this axle is going to be rotate with the help of this split ring. So split ring is connected with this rod right now. When this split ring will rotate, so this rod will also rotate. Now the question is here, like the split ring is connected here. Now this split ring, when it is like covering the thing is like this, the rod is here, so it is rotating it like this. When it is on the above part, when it is not connected with the brushes, it may be the condition when there is a no connection in between this split rings and the brushes. At that moment, what will happen? So at that moment, due to inertia, due to the motion that is we have provided in this split ring, is going to be again having a inertia, lot of inertia on this part. So it is again going to move itself in the direction that in which it is going previously. Okay, so that brushes are used for providing electricity. Split ring just to hold on the things perfectly organized in a circuit, so that it will not like tie up with each other like this and make it complex. And this coil again is the major part because it is going to rotate itself, and this is the horseshoe magnet. Okay, and the battery part, you know, for providing current, you know, you need the battery part also. So this is what the construction work is here. And now let us see the working of this. So as I have told you, battery is here. So as you can see, the battery part is connected, and with this the brushes are connected, and that brushes is going to be attached with the split ring. So now due to the force that is generated into the rectangular coil here, A, B, C, D. As you know students that here north and south. So here in this direction are, okay, according to the diagram we are having a north in this case, or here the south in this case. Okay, that you can take in that manner also, that is also correct, and this is also correct, both are correct. Okay, let us take according to the diagram only. Now as you can see here north and south, so here accordingly we are having the magnetic field lines like this, and currents positive terminal here and negative terminal here. So positive to negative like this. Okay, as you can see now students, for this particular wire, let us say it is lying in the magnetic field like this, like this is the coil and magnetic field is going in this manner. Okay, now the magnetic field lines are cutting it very much because it is perpendicular in the way. I have told you that when the current carrying conductor is perpendicular to the magnetic field line, then we can say that it is making the maximum force. So for this particular position, it is making a maximum force. Now for this maximum force, with the help of Fleming's left hand rule, can we find where the force is going to be produced? Let us see FBI. Okay, FBI. So now just take the B part in this way. Okay, it is going to be in this way, and current, it is going to be in this manner because it is going in downward direction for this particular wire like this. So now thumb is in your direction, like it is going into the outward direction of this board. So it is going to be downward. Like see here in the diagram, as you can see, the rod, whichever it is at the north side of the magnet, is going in downward direction. And now see the direction of for this particular wire. As you can see, again we can use this left hand Fleming rule. So magnetic field here in this direction, current is going in upward direction, and the thumb is in my direction now. So in my direction means here it is coming in the above, like here in this manner. So as you can see, it is going in upward direction. So this is the basic things that you can learn, and you can see, you can observe how this motor works. It is going in between the north and south pole of the real magnet, and the magnetic field that is produced in this coil is going to generate certain force that we can find with the help of left hand Fleming rule. And now see what is happening here when these coils, like here in the first case, as we know that it is lying in between the magnetic field, so that maximum number of flux are cutting through it. But when it is going to be in this manner, okay, when the coil is going to be in this manner, so minimum number of flux means the magnetic field lines are going to be cut from the coil. So maximum part of this is going to be passing through in between. So we can say at that point it will feel minimum, like when it is in this direction, as I can draw it here, it could be in this direction. जब ये थोड़ा इस तरीके से हो जाएगा, like this, okay? So जब ये vertical हो जाएगा, अभी ये horizontal है, when ये vertical हो जाएगा तब बहुत सारी फ्लक्स इसमें से पास ऑन हो जाएगी. सो वी कैन से कि अभी बहुत कम मैग्नेटिक फील्ड लाइंस आर रियली इन कॉन्टैक्ट विद दिस coil, so it will feel minimum force. So minimum force, but still it is moving. Why? Because of again inertia. As I have told you, due to inertia it is having the motion property and it will going to follow that, okay, due to the four laws of motion that we have seen in the first law. Any object which is in rest position will be in rest unless and until it is going to have external force, and any object is in motion will always want to be in motion again and again unless and until again we are going to provide external force to stop it. So this is what this coil is doing. It is moving in continuous direction because it is having inertia at this moment. I hope the working of electric motor is very well understood to you people. Students, we have seen the working part of electric motor as well, and I have told you earlier that this was just a rough diagram, but in actual it is not like this, that electric motor is having such kind of original shape and size. So what is there that is going to produce a more work, like in the particular diagram that I have shown you already, is not going to be produce a lot of more force. So how we can generate, what we can do to commercially use it so that it can generate more and more power or more and more force. So here are some basic things that we can do using electromagnet in place of permanent magnet. Okay, so when we are using the horseshoe magnet, you know that north and south pole was there. So in that case, for a particular thing we can use electromagnets, because electromagnets are also generating the magnetic field here, and the magnetic field that is generated by the particular coil that is kept inside this electromagnet, because you know that electromagnet could also be a round in shape, and inside that only we can just put a coil here. So that is going to produce a lot amount of force, and that is commercially used, okay, commercially. And when you are going to see any kind of motor, then you will observe that here this is of cylindrical shape like this, okay, जैसे बैटरी होता है इसी तरीके से कुछ होता है इसमें इस तरीके से, and we are going to connect it like through the plugs. So it will the axle part of it, it's going to rotate the fins or any item that is connected to it. Okay, this is a part that we can use. So electromagnet is this circle, this cylindrical things. So when we are using electricity already, you know, so a part of this that we can use a permanent magnet. Permanent magnet is not long lasting and it is not going to provide a lot of magnetic effect, but using the electromagnet is going to help you a lot of variant thing. Okay, so electromagnet is what is producing the magnetic field according to our wish. If we want to reduce it, we can reduce it. If we want to increase it, we can increase it. That is what the function of electromagnet. It is depending on the electricity. And when we are providing the electricity to the coil, so we can provide the electricity to this also. Because eventually what we need in the end, as a product, we need a mechanical force. For that, we can provide electricity to both the things. Okay, so we can use electromagnets in place of permanent magnet. Second one is large number of turns of conducting wire. In that case, we have just taken one loop like this. Yeah, right? So this is just a one loop. So why can't we take a multiple loops like this? Okay, this is not in exactly square shape. We have just taught you in this manner, and because NCERT is also following the same manner. So here, this is going to give you the idea that how the particular this side of the conducting wire is when going to be perpendicular to the magnetic field line, so it is going to feel the force. And for using Fleming's left hand rule, so that we can observe the direction of the force That is why we have used such kind of. But in reality, it is in this circular part and it is not a single loop, it is a multiple loop. Okay, and this is the third thing that we can do is taking this soft iron core on which the coil is wounded, and even the coil is going to be rotated. It is not going to be rotated like this manually. Okay, it is going to be rotated on a rod, that is a soft iron rod. किसी rod के ऊपर वायर को लगाया जाता है. अब आयरन है, it is again a very good conductor and or going to be enhance the electromagnetic properties here. So this is again going to be very, very useful. So this is how we can commercially increase the force that is produced by the electric motor and the power of motors.